Hi, Tim Unker here. I'm going to make a short video this morning. I'm ready to go bike riding, but I'm just waiting for the sun to come up. Uh, so this video is going to be on creating a worksheet using Python, and we're going to automate the worksheet. We're going to create it to a PDF or to an HTML file first, and then we'll use that to create a PDF. And we'll get going on that. I'm going to use NeoVim today. If you're interested in videos like this, please like, subscribe, and hit the bell for notifications. It really helps the channel grow. You can also follow me on GitHub, and I'm going to put this worksheet up on TeacherPay Teachers. That's another way to support me. All right, let's get to it. Okay, so let me move this, and let me get this a little bit larger for you. Okay, and I have a folder called PyAlgos for Python algorithms. We're going to make another directory. Let's call that, we're going to do complex number multiplication. So it's going to be complex number mult dash or underscore yt. Let's do it that. Let's actually do this in snake case. So complex number mult underscore yt. Okay. And I'm going to cd into complex number mult underscore yt. And now with NeoVim, let's create a file. Let's call it complex underscore number underscore mult underscore yt dot py. Okay. All right. So first thing I want to do is I want to create a class, and I want that class to be called, let's do complex, let's just call it the complex multiplication. All right. And now I'm going to go down here for a minute, and we're going to go outside of Python, just show you what I'm talking about. So we're going to have something like 4 plus 3i times 2, let me say, or plus, I don't know, well, actually, let's just do positive numbers. So 2 plus 5i, something like that. So we need two constants, in this case, the 4 and the 2, and we also need two coefficients, in this case, the 3 and the 5. Okay, so we're going to need those. So when we instantiate this class, which I'm going to do now, we're going to pass in the self. We're going to pass in constant underscore 1, constant underscore 2, coefficient underscore 1, and coefficient underscore 2. And then I'm going to say self dot const 1 equals const 1, self dot const 2 equals const 2, self dot coefficient 1 equals coefficient 1, and self dot coefficient 2 equals coefficient 2. Okay. All right. So now we've instantiated our class. Now we have to create a couple methods that will help to basically find the product. So we have to have the product of the reals and then the product of the imaginaries. Now this is interesting with complex numbers. So we'll go back to our examples. 4 plus 3i, I think it was times 2 plus 5i, something like that. Anyways, so if we do this, we're going to do 4 times 2, right? And then we're going to have plus, then we're going to have 4 times 5i, so 4 times 5i plus then 3i times 2, just doing, first, outer, inner, and then last, and then we'll have 4 times 5i, or sorry, 3i times 5i, which is going to be 15i, or well, let me write it out. 3i times 5i. All right, so this is going to simplify. 4 times 2 is 8, plus, then we have 20i, then we have, let's see, then we have 6i, and then we have 15i squared. Now, I, imaginary number, is the square root of -1. So when you have I squared, you actually have, instead of I squared, we have -1. Okay, so really, the product of the imaginaries is going to be 26i, but then we have 8 minus 15. So we have negative 7 plus 26i for our solution. Okay, so we're going to need to figure out how to do that when we do our problem. All right, so I'm going to go up here. Let's just leave that there for now. That's obviously going to throw an error if we try and run it. But so we want to find the product of the real numbers. Okay, so that's going to be one of our methods. We'll pass in the self. And the product of the reals is going to be constant 1 times constant 2. So we'll say product. Let's call this find product reals. Find product reals. And then we'll say product reals. That's going to equal self times constant 1, or self.constant 1 times self.constant 2. Okay. All right. But it's also going to be plus, or actually minus, and then we'll do in parentheses, right? Because we're doing the minus, it kind of accounts for negative 1. Or another way you could think of this, we could do, if you want to do the plus, we do plus negative 1 times, then in parentheses, we're going to do coefficient 1 times coefficient 2. All right, the last terms, because the negative 1 is going to represent the I squared. So we'll do self.coef 1 times self.coef 2. Okay, and then for this method, so that'll give us the product of the reals, or what the reals end up as. And so we'll return, technically we're adding a little bit, so maybe calling it the product of the reals isn't the best, but for this example, we're going to just call it product of the reals. We'll return that. Okay, and then we're going to create another method, which is find the product of the imaginary part of it. All right, and that's going to be, so the product of the imaginary part, well, that's going to be, let's see, it's going to be the constant 1 times coefficient 2. So self.const 1 times self.coef 2 plus self.constant 2 times self.coefficient 1. That's like the middle part of the FOIL, the outer and the inner. That's going to give me the imaginary part. So we're going to return that. And that's going to be it for our method. All right, so let's get rid of that so we don't keep it in and have it throw an error. Let's import the random module. So I can create some random values here. And what I'm going to do here is I'm going to create a random num list. I've done this before in other videos, and we're going to leave it blank for now. And then we're going to say for num, no, let's say for x in range, we'll go from 1 to 101. So we'll go from numbers from 1 to 101. We're going to just take this random number list, and we're going to append x. And I like doing this because that way we can automate the process of writing in numbers 1 through 100. It goes up to one number less than you specify for our random number list. Now, we also want to create some files. So I'm going to have a complex multiplication file, and that's going to, we're going to say open complex-mult.html, and we'll append to that. And we'll also do a complex multiplication solution file. That's what I'm going to write next. And we're going to open, and we'll do complex mult sol.html, and we'll append something to that. Okay, so now we're going to say for problem in range, we'll do 100 problems, so 1 to 101. Okay, and what I'm going to say now is, let's see. So now I'm going to, well, first let's create the constant 1, constant 2, coefficient 1, and coefficient 2. So I'm going to say const 1 equals random dot choice, and we'll pass in the random number list. Okay, and let's just do constant 2 and coefficient 1 and coefficient 2. Okay. All right, so we've got our values that we can pass in. We also want to create a new problem. That's going to be our object. So new problem equals, it's going to be a complex multiplication when we pass in const underscore 1, const underscore 2, coef underscore 1, and coef underscore 2. Okay. All right, so we've got our new problem object created. All right, so now what we're going to do is we're going to come up with some strings that I can use for both the complex multiplication file and the complex multiplication solution file. So the first string we're going to make is just the problem number string. So I'm just going to call this problem number, and it's going to be a format string, and we're going to say problem, and then we'll pass in the actual problem number. And then we'll do a /n to move to the next line. In here, we're going to be passing this to an HTML file. So what I want to do is I'm going to use H3 heading, and we'll put that in there. Okay. All right. And we're also going to have the actual problem. That's going to be a format string. So I'll say something like multiply. Oh, that's my alarm. Let me dismiss that. I should be getting up and getting ready for a bike ride. All right, so we're going to multiply now the two complex numbers. So I'm going to pass in const underscore 1 plus coef underscore 1 times I. And then we'll have pass in const underscore 2 plus coef underscore 2 times I. And one of the things I want to do here is I want to put this in a paragraph. So I want to wrap that in a paragraph. Move this up. And then also just do a /n for formatting reasons. Okay, and we also want to have the solution, which is going to be an F string also. This works on Python 3.6 and higher. So we'll have this in a paragraph, and we'll say solution. And the solution is going to be so pass in new underscore problem dot find product reals, and that's a method, so we have to put the open and closing parentheses, plus, and then we'll have new underscore problem dot find product imaginary, and we're going to run this into the other line, but then that's going to be times I. Okay, and we're going to close out our parentheses and just do a /n for formatting. Okay, so now we're going to write some stuff to our files. So we're going to take our complex multiplication file, and we're going to write the problem number. And we're also going to take our complex multiplication file, and we're going to write the problem. And we're going to take our complex multiplication, the solution file, and we're going to write the problem number. And we're going to do our complex multiplication solution file, and we're going to write the solution. Okay. And at the end here, now we've got that stuff going. So now we need to close these files. So we're going to take our complex multiplication file, and we're going to close it. And we'll take our complex multiplication solution file and close it. And all right, so let's open up our terminal and run this program. All right, So I'm going to run the program with Python 3 and then the name of the file. And we ran it without any errors. Now, if we list out, we see that we have the HTML file and the HTML file for the solutions. So I'm going to exit out of the terminal and let's go into our multiplication file and let's add a few things. Okay, so if we were going to put this as an HTML file in the web, we'd want to do a few more things, but let's declare a doc type of HTML, and let's have an HTML opening tag, and let's go to the bottom here and an HTML closing tag, and also let's put a body closing tag here, and go to the top and have a body opening tag. I'm going to worry about this formatting in a second. Okay, we'll also have a head tag opening and closing there, and we'll also have a couple basic stuff. So we want our meta car set to be UTF-8, and the viewport, we want to set that. We'll have a content equal width equals device dash width, initial scale equals 1.0. All right, and then we'll have a title, and the title is going to be complex number multiplication. Close out the title, and typically I bring in a style sheet, but we're just going to do a couple like little styles on the top here. This really isn't best practices, but again, we're not doing this on the web. We're using this to create a worksheet. All right, so a few things I'm just going to do. Body max width of 800 pixels, margin left auto, margin right auto, and then we'll just give a little padding for the H3. So we'll have a padding of 20 pixels, and then the paragraph will also have a padding of 20 pixels. Okay. All right, so I'm going to go to the top of the document, GG, V to go into visual mode, Shift G to go down to the bottom, Shift dollar, and then the dollar sign to go to the end of the line, and hit equals. And let's see if it did that for us. Yep. So what that did is formatted the document with the proper indentation. Okay. So let's now save it, and let's take a look in our browser what the file looks like. All right. So we're going to go to the Linux files, pyalgos, complex multiplication.yt. Okay, this is the file. And we'll see we have the problems here. And you go down, we have 100 problems. Nice. And we can print these out. All right, one more thing I want to do, just a couple of basic things. Let's go here. Let's create a paragraph here, put some place for the name. Another paragraph, place for the date. You can put something like a class or something like that. And then go to the bottom of the document, and we're just going to make a paragraph with a style equal to text align center. And we're going to just say something like copyright, copy 2021, Timothy Unkert, all rights reserved. Close out our paragraph tag. And yeah, so now if we open it, we'll just see those changes. So we go here, let's open that, we'll view it, and we got the name and the date at the top and the copyright at the bottom. All right, and we're going to do that same thing with the solution file. I'll put this worksheet up on TeacherPay Teachers for $1 in case you want to support me in that way. Or just a free way to support is liking, subscribing, and hitting the bell for notifications, or following me on GitHub. I'll leave a link to my GitHub profile in the description below as well. And just watching the video is support enough. Thank you. It's time for me to go on my bike ride, so I'm going to stop now. And thanks for watching. Have a great day. Hope to see you in the next one.